Hello, it's Duncan. Last week we introduced HTMX to allow UI updates without refreshing the whole page. That worked well, but we didn't really have a testing strategy. This week we try out the Playwright library to allow us to run tests in the browser and devise a nice technique to check if our pages are rendering properly after a partial update. We finished the last episode having introduced HTMX so that we can refresh only parts of the page. So we could add items this way, and if I click add, you'll see the page doesn't refresh, but we have got our item down there. So we re-register the table, and in fact we can do the same thing, delete that, and there it's gone. But again, we only refresh this table. Now that's clever, but it leaves us with a problem, which is how to test these interactions. We haven't written any JavaScript, but they're working because of JavaScript, so they're working in the browser. But when we look at our tests, here's one for delete items. What we're having to do is simulate what HTMX is doing, which is submitting a post with a particular header, and show that we're responding with just the table element, but we don't know that our web page has put that in the right place, so we don't know that the user is seeing the right thing. If we want to know for sure that it's working, we're going to have to run up a browser. And in the comments of the last video, Billy Talent Rocks 345 was good enough to recommend Playwright Java for browser tests. So in the interest of having confidence in what we're shipping, let's have a look at Playwright and see how it can help us with HTMX. Here's the Playwright website, and it does indeed have a Java implementation. So let's have a look at that. Let's have a look at the docs, and we've got installation. And it says, well, it shows us how to do a thing, but first of all, we'll need to reference the libraries. It gives us a pom.xml, which is a little bit old-fashioned these days, but here are the important bits. We have a dependency. So let's copy that. And now over in our build.gradle, it's a little known trick that you can just paste a Maven snippet and IntelliJ will convert it to Gradle, which is rather nice. Thank you. We don't want this to be implementation though, we want it to be test implementation because we only want to be using Playwright in our tests. Okay, we will import those changes. Good. And now let's go and have a look at that example. So it says we can do something like this. Well, let's just take that Java. And in our tests, I think we'll add, well, let's just say here, we'll say new Kotlin file, and we'll say this is delete items acceptance tests. Add that. And now we'll paste everything and convert it to Kotlin. And now if instead of main, we just make that a test, then we should be able to run it. Let's have a go. Okay, it started. Let's have a look at what's happening as we run it. Okay, so it looks like we are downloading a version of Chromium and FFmpeg and Firefox and WebKit. Okay. Oh, and then our test ran. And did we get a page title? Oh, yes, there it is. Look. The page title is Fast and Reliable End-to-End Testing for Modern Web Apps, Playwright. Now, I think I'm going to assume from the code here that that actually launched a copy of Chromium, which is an open source version of Chrome, and actually loaded the Playwright web page in order to find the title. But we didn't see it, and it's always nice to see these things running, at least locally. So let's see how we can see the browser window. Here we are, look, right under the example, it says you can use launch with a new browser type launch option, set headless, so on, set slow-mo, so on. So let's take that and paste it in there. Okay, and now let's run again. Oh, and there we saw a flash of a browser, splendid. Well, that's a start, I suppose, but we don't really want to know anything about the Playwright page. We want to know about our own app. So I guess we're going to have to start that. And our normal delete items tests has has a way of creating our app. So we start with some sort of setup here. Let's take that, because the useful thing here is it starts with its items in memory and with some pricing built in so that our test will be consistent. So let's copy all that for now into our acceptance tests. And now, before we start Playwright, we should be able to go to our app and say app.roots. Now, in our previous tests, these ones here, delete items tests, especially the HTTP versions, we could talk to the roots directly. We didn't actually need to start a server. But Playwright will be talking over HTTP, not in memory. So we need to start a server, and we can look at our test main to remind ourselves how to do that. So here we've got server for port roots start. So let's take that maybe, go into our acceptance test and say, that is our app.roots. Now, sooner or later, we want to stop the server in order that other tests can start a server on the same port. But for now, I think we could probably just go to localhost on that port and see what the title of our app is. Let's run that. Oh, and this has failed. Why is that? Oh, well, look, that's because I'm running test main on that port. There it is at 8088. I wonder if there's a way to use a random port for a server and then find out what it is. I think for now I'm going to solve that problem just by picking a different port in here. And we'll solve the problem of clashes between tests later on. One more go. Okay, well, something happened because we saw a browser. Let's have a look at the trace. And there it is. Gilded Rose is our title. Well, that's good. Okay, now we could make assertions on the page title, but that's probably the least interesting thing. I guess we probably want to know that the page content is the one we expect. Now, in the past, we've used approvals tests for this. So in our list stock test, for example, we have an approver here. But the problem we found is that every rendering change we've made, we've had to approve both the output from the stock list rendering tests and the list stock tests. And that's becoming a bit tedious. But it occurs to me we could ask a different question. We could say, is the page the same as the renderer would produce? Because the renderer is well tested. So here, instead of saying approver assert approved, I think what I'm going to try is getting the response. And now I'm going to say assert equals something is the response.body string. And that, I think, should be whatever our render would render from our price stock list. So in here we can say render, or render wants a result of stock list. So we can just give it success of the price stock list that we used to populate our fixture. And now a few other bits. We need the rendering time. Well, that's our same day as last modified. We need zone ID. That's the zone for our app, which is London, I think. Got that lying around, good. And the features, well, that's the features that our app has been built with, which is currently just the default features. And finally, whether we're rendering just the table, and the answer is no, we're not. We're rendering the whole page. So what we've said is the thing we get back the same as rendering the thing we expect to be rendering? Let's run this test to find out. No, it isn't, apparently. Let's have a look. Oh, that's odd. We're seeing the headers. What have we done? Oh, I guess our render actually returns a response. So if we go back, we can say, in fact, that that response should equal that one, maybe. So if we go. Now they're not, but I suspect that's because of some headers that we are adding in our app. So let's just check that's true. And lo and behold, it's our trace headers. So what we really want is the response body string is the same as our body string from our render. Is that good? Yes, it is. Now, this is a bit of a bodge at the moment, but it does mean that we can get rid of the approver because we know that whatever we've approved is the same as this rendering here, I think. So let's get rid of that. And then we can remove that. And we can get rid of our approvals test for our list stock. And then we can delete the approved file from in here as well. Check that by running all of our list stock tests. And we're good. I think actually we did just lose the check for the status code. So let's put that back in. And I'm inclined to start using strict more. It was certainly my favorite of the assertion libraries. So with strict, we can say expect that our response, and HTTP4K has some strict matches as well, but I'm not sure we're importing them. Let's go and find out. I think if we duplicate that and say strict, import, that looks good. Back to our list doc tests. So now in here, I think we can say status is equal to OK. And then we can also say body string is equal to the thing we thought of down here. Is that true? Yes, it is. So now we can delete that version. And just to check, I'm going to say, what happens if we tried something else in there? Run that test. And here you can see we get a nice strict output. Well, it's a bit big maybe, but it says expect that OK is equal to 403 forbidden, but found 200 OK. And in an expect that block, all of these assertions are tried. So we see which ones are true and which ones are false. Back to OK and run. Good. Now there's quite a bit of duplication here in this call to render. I wonder whether we can do better. First of all, these features, that shouldn't just be a features. I think that should be whatever apps features are. So we'll say app.features. This same day as last modified, well, that's the time of the clock of the app. It's what we said here. So I think here we could say that this is app.clock invoked. See if that's right. It is. I think we might say that this price stock list and this one are both the expected price stock list. So let's make a variable out of that, which is just that one for now. This is expected price stock list. So we put it into the fixture there, and it's what we expect out at the same time. So we take that into there and there. And in fact, probably it would be better to make that the result, so that we could say that and that. Is that true? It is, and that just leaves us with this London zone ID, which is a bit random, really. Unfortunately, at the moment, we're not configuring our app with the zone ID. It's just hard-coded, but I think we'll leave that alone, come back here. And now we can take this thing, I think that, make a method out of it. And this is going to be expected rendering for, and we've lost our clock for some reason. That just seems to be an IntelliJ plug. That's app.clock. And this, and its type should be instant. I think in some ways IntelliJ's refactorings are getting worse. Right, and now if we make app the subject of this, I think we've got a nice thing that we can use elsewhere. So let's take that out of this test, and I'll just put it down the bottom as a sort of test utility that's generally available to tests in this package. Run that. Good. Actually, I see now I can mess this up. This clock can actually just be this dot clock, which is the app, which means that that one's not required. And now I can get rid of this. Is that true? Why, yes, it is. And now in context, this is not expected price stock list, but just the price stock list. Now we can go back to our acceptance tests and say the same thing we said for our list stock tests. So here we said, expect that response and so on. So we'll take something like that. We'll go to our acceptance test. Now, we don't actually have a response, but what we can do is ask the page for its content as a string. I think we'll assume the status is okay if the browser has rendered it. So we can get rid of that. So now we're saying expect that the page content is equal to the app's expected rendering for, and what is the expected price stock list? Well, that's the price stock list from here. As a success, import that, and I think there's a chance that this will work. Oh, but I was wrong. Let's find out why. Oh, in the middle time we actually have a click to see the difference. And now what we're seeing is the difference between the HTML we sent to the browser and what it implied from that. So in particular, we didn't send a table body tag, so it put one in for us. At the top here, what do we have? Well, HTMX added some styles for us. That's something that wasn't in our initial document, but HTMX put in for us when it loaded, I guess. What's this bit here? The browser has stripped out the white space there. What's happening here? It's interpreted our required as required equals quote, quote. Well, again, I guess it's a fair cop. And there's the end of the table body that we didn't put in, but it has for us. Okay, it feels to me like this is going to be a problem because here we're using Chromium, but I suppose the content interpreted by other browsers will probably be a bit different. Okay, I think for now at least, I'm going to kick that can down the road. I'm going to say we'll rely on our lick stock tests for the actual content of that page, but we'll use this test to interact with it. So this is our delete items acceptance test. How does the user interact with the browser to delete items? What I'm going to do is I'm going to set a breakpoint in this test so that we can explore the UI with this fixture, with just the 3 items. I'm going to wait until we've got a page. I'm going to set a breakpoint here on the line, and I'm going to make sure that we suspend only this thread so we can carry on interacting with our server. Okay, so now we're going to debug this. And you saw there our test Chrome running. Here it is showing the stock list from our test. So when we delete, we select some items, maybe just one, and we click the delete button. So in order to interact with that via Playwright, we're going to have to find this item. Let's inspect that. Hasn't done a terribly good job of looking inside the table. Table, table, table row. That's our header. And here is our new item row, so we don't want that one. Here is our banana, and let's go with the kumquat, the one in the middle. So its name is K1, and that name is the ID of our item. Okay, so what we need to be able to do now is click on a checkbox with a given name. Here in the documentation, you can see how we click. So we have a locator. So we ask the page to find something for us, and then once we've got a locator, we can call click on it. So I think we'll stop the test for now and have a look at that. Kill that. And now, so we've navigated, we've got the title, which we don't need anymore. So we're going to say my checkbox is page.locator. And we have quite a few options here. We've got get by label, but we don't have a label on our checkbox. Well, it's basically locator with a selector. Let's have a look at the documentation for that. And it says a selector to use when resolving a DOM element. Maybe this is one of those AI moments. Let's ask, what Playwright locator can I use to match a checkbox with the name, I don't know what, say Fred. Well, I must say that looks plausible. Let's take the bit out the middle, copy it, put it in here in a raw string. And we didn't want Fred, we wanted the ID of our item. So in here we'll put $, and this is going to be our price stock list at 1.id. Let's try clicking that. So we say checkbox.click, and then we've got a breakpoint here, so we will pause in the debugger and see whether that's worked. So let's rerun the debugger. There we are, stopped. Let's go and have a look at the page. And oh my goodness, it has worked. Splendid. While we're here, we'll just see how to find this button. So we'll inspect that. Again, not terribly usefully. So this is our form. There's a delete. So we're looking for a button, a submit button with a value of delete. Let's stop our debugger. And now I suspect that we should be able to do the same sort of thing here. So we'll say duplicate those, say this is my button, which is an input with a value of delete, and a type was submit. And now can we click that button? We know that this doesn't work, so we can take it out. And I think save the tediousness of the debugger, we'll just say thread sleep for a while. And here, rerun. That doesn't appear to have deleted. Let's just check that it will if we do it manually. Did you see that? We have our confirm is popping up and just disappearing. Let's see what we can do about that. Again, maybe AI. How do I use a confirmation dialog in Playwright? Well, that's quite useful, but very JavaScript-y. What about in Java? Okay, that carried on going for a bit, but I say page on dialog, dialog accept. Let's just try that. So before I do the button click, I need to say, here's some Java, convert it to Kotlin, do that, and run again. And oh my goodness, it just worked. Fantastic. Okay, then we should have some assertions. And if we look back in our delete items tests, the normal ones, here we are deleting 2 items, and then we're checking that when we reload the stock list, we only have 1 item left. So let's take that, I think, and put that in here. We have a compilation issue here, which is, context receiver found. So we're going to have to do this thing, because we're now interacting with actions in our application. But that's no real issue. Except for some pathological import problem that I don't understand and will skip over. So back down here, that compiles good. But we need to delete 2 items. So in fact, we need to delete item 0 and item 2. In fact, we can say dot click and dot click. And now we can get rid of those and delete that and see whether that's all true. My goodness, it is. So now we've shown that using the user interface has affected the stock list on disk. But the question in my mind is the user interface showing the right thing? Now, what is the right thing? Well, the right thing is what we would have showed if we'd listed the stock list directly rather than swapping things in and out the DOM. So I think we should be able to say that once we've done all of our things, we should be able to get the rendered page, which is our page content. And then if we reload the page, we'll see what the current stock list rendered completely should look like. So we should now be able to say that the new page content is the same as the rendered page. And if it is, that'll show that our substitutions, the ones that happened here when we click the button and so on, have been put into the right place. That our page looks as if we'd done a full page reload rather than just substituting things into the DOM with HTMX. So let's give this a go. and that fails. Let's see why. Now you can see these are very similar. First difference here is that we've gained an empty class declaration on our form. And we've also gained an empty class declaration here on our table. Now I believe these are due to CSS transitions. HTMX allows you to animate its DOM changes. I think it doesn't completely tidy up after itself. But more interesting here is that we've got two table tags. Now I don't know how to make HTMX tidy up after itself, but what I do know is how to just get rid of empty class declarations from a string. So let's start by doing that. We can take our page content and replace anything that says class equals quote. And we're going to need lots of quotes in order to make that work. And I suspect that a space before that. So then we have 1, 2, 1, 2, 3. Delete those two. And we want to replace any empty classes with an empty string, like that. Oh, and one too many quotes at the beginning. Try that. Okay. And now we have the issue that we have two table tags. And I think we may find that we've got an extra table end down the bottom. That's a bit weird, but it does remind me that when we first interacted with HTMX, so if I do this, this, and this, when I click a button, I don't know whether you saw it there, but the table just jumped a little bit. I think if we inspect this, we'll find, there we go, we have two tables in here. Now going back to our rendering template, if we look up in our form, we've got the target of table, but it turns out the default HTMX behavior is to replace the inner HTML of the target. So what we're doing is we're replacing the content here of our table with our response, but our response is the whole table. So in fact, what we need to do is set hx swap equals outer HTML. And we'll need to do the same thing with the other form. Now if we run our tests, the only difference we have are some blank lines in our source. We've lost the nested table. And now if we go back to Firefox and reload this page and click add, then we don't get the little jump. Hooray! So now we just have to account for the blank lines in the output. Let's remind ourselves which way around they were. We want to remove, well, the simplest thing would be to remove any blank lines from both sides, I think. So let's come back here, go back to our acceptance test and say that our page content with no blank lines is our rendered page, replacing all the things with no blank lines. What does no blank lines look like? Let's create an extension function on string, which wants to return a string, and it can return this lines filter. It is not blank, and then join to string using a character return to get our lines back. I wonder whether empty wouldn't be better, just to be on the safe side, is not empty, and then we can rename this to be with no empty lines and run. Splendid. I think we've made quite a bit of progress today. It's a bit untidy. Maybe we could just, let's make this thing into method with no empty class attributes. Make that the receiver. Take that out of there into there. Just lay this out a bit better. And now I think up here we might say, we don't need to know anything about the button for now, but this can be a method of delete button. Don't know what happened there. It's potentially nullable, so but I think, does locator always return something? Well, I think with Playwright, it either finds something or throws an exception. So I think we can go back here and say that's fine. but this is going to take the page as a receiver and make this a property of delete button. Again, that can come out to the top level as generally useful. And then here, I think we've got the same sort of thing. If I take this as a val, then take this thing as a method. This is checkbox 4. Do both of those. Back here, this is again not going to fail. Make this the receiver. And then back here we can say inline that. This thing I think we can say is a method which is accept dialog. Again, make that into a receiver. Again, take that out as a useful thing. Again, take that out as a useful thing. So now we're saying do some stuff to create our app and start it. Start up Playwright, open a new page, navigate to our home page, check 2 checkboxes, click the delete button, show that our stock has actually been affected on disk, render our page, go and get the rendered page and check that it's the same thing as we would have done had we just rendered the new stock list. Phew. Run all that. There we go. Now it's working. I think we should be able to take this bit out so that when we run it, oh dear, that's strange. It seems that when we're not showing the browser, it doesn't work. Let's just try that. No, but if I comment that back out and run again, then we are good. Is it the slow-mo or the headless that's required? Let's get rid of that bit and run. It seems we need to be running slowly for some reason. Instead, if we get rid of set headless and run, we're okay. Well, what are we to make of this? I think the answer is probably that whilst Playwright is very good at waiting for things to appear in the DOM and to settle down, it's not waiting after it's clicked the button for our server to have returned a result. Maybe if we say thread sleep just a little bit in here, we could get rid of that. Let's find out. Yes, we're right. At least once. Okay. Again, to AI Assistant, how do I wait in Playwright for all events to have been processed? Well, here's some answer around page wait for response. Let's see if we can translate that ourselves. So we'll say page dot wait for response. I don't know what goes back in there. URL predicate pattern. How do I do that in Java? Well, that looks as if I could cope with that. Let's put that in there. Okay. Apparently we need a pattern in there or a predicate over a response. Let's say pattern compile that thing. Maybe just dot star. Still no joy. But this looks like it takes a runnable. So I can do something like this thing does. I don't know. Maybe we're just going to wait and I can take that out. Is that true? Run. It is not. And the reason is, and we're now back to the classes for the CSS transitions from HTMX. But that is after we checked this. So it looks as if that thread sleep isn't required there, but might be required down here in some sort of way. Let's find out. That's good. So now we need to find a way of waiting for HTMX to finish its processing. I think that's a job for next time. So let's just tidy these up and run all of our tests. And no doubt we'll now have one approvals test to fix. And here it is. So those are our changes to our rendering. We can approve just one thing now and run. Good. Well, this browser-based test is by no means finished, but it did actually find the issue we had with putting a table inside a table in our rendering, so that's good. I think I'm going to commit it with add work in progress, delete items acceptance tests, and tidy other rendering tests. Because our list stock tests, I think we have improved with our expected rendering for all. Okay, commit that. And my goodness, we have a lot of warnings. Let's just check those. Well, we have an HX swap issue, and oh my goodness, who knows what is going on in Gradle? Nobody can tell. I think that'll do for today. Reviewing what we've done, we discovered that Playwright is quite a painless way of running tests in a browser, although we do have concurrency issues where we're doing things inside the browser and then checking the state of our system. It did find a bug though, so that was nice. And it's encouraged us to go to our list stock tests and do something about the fact that every rendering change had to be approved in two places, by adding this facility to check the page is the same as the output of our rendering function. Next week, I think we'll end up tidying up these acceptance tests and adding some for our add item. And the more we use a thing, the more we normally find nice abstractions and ways to communicate what our tests are doing. So I'm looking forward to that. If you'd like to see it, then please like this video and subscribe to the channel. And if you enjoy what I'm doing here, then I think you'll enjoy the book that I wrote with that price called Java to Kotlin, a Refactoring Guidebook, details of which are in the show notes below. Thanks for watching.